So here, there's a throw blanket on the back garage, and then there are a couple of different fire extinguishers. This is my go-to, just as ABC Chem. So if something happens, pop it off right there on the machine. I'll just use the throw blanket first. First thing, just remove the power. 9 times out of 10, that'll stop it, taking the heat away and the power away. So just shut it off. I'll show you that today. And then if that doesn't work, the throw blanket. If that still doesn't work, go ahead.
Get it dirty.
We'll have some cleaning.
Get it dirty.
So here's the other throw blanket here.
Okay.
So what you just is this covers this machine and the Bumblebee. The other, so that's the yellow. Okay, so that covers that. Also in this room, it has an air exchanger. And so if for some reason you fill this room with smoke, then you can air exchange this room. This is the only facility that does it. The other room does not. So we're over there, you're not going to see this feature. But basically, there's an in and out. You throw them both, and you'll actually hear them. And it'll literally just dump all the air out of this room. It'll, just because of that little bit, you'll feel it start to get cold down here.
Okay.
I mean, it's really, really effective, right? So that's there if this thing smokes out on you. What can you cut on it? I think that's always a thing, you know, like a cover next, right? So you're not cutting metals on this, and I'll send you a paper that has a description of what you can and shouldn't cut on it. Basically, on that list is a list of safe items, and also if you Google CO2 laser cutting material safe list, you'll see the safe list. There's some things like foam or some like foam materials you shouldn't cut because when you cut it, it creates chlorine and it messes. So it's not necessarily the material wouldn't be cut, but the byproduct of it heating is a problem. So that's the story with all of that. So let me think. There's that. There's anything else around the safety components? I think that's it. The only other thing is there are safety glasses around. If you have to leave this shut when you're cutting, this should give you this cover should give you adequate coverage. But if you're looking at it, there are some glasses around here. Yeah. No, these are not. These are some safety glasses.
Those are green tint.
Yeah, they got a green tint. They're probably over here. But if you're gonna like watch it, you shouldn't really stare at it. It's pretty bright. So think of it like a welder. If I want to look at it, a lot of times I'll look past it. So I'll get over top of it so I don't see that hot spot. But I can kind of watch around it. Yeah. Just to kind of keep my eyes from bugging out on me. So that's that. So let's go. Let's start in the software, and I'll go into the machine, and we'll start the machine up, and we'll do some cuts. Did you happen to watch any of the videos on YouTube or anything like that? Okay, that's no problem. All right, let's do this then. Let's get this out of the way. So if you guys want to grab some more chairs. So you know that all the computers have the same username and password. It should, whatever it is on the screen, that's what it should be for the password. So IFMS should also be the password. Okay. Whatever the username is, it's also the password. Yeah. Okay. Excuse me. So we're using Lightburn today. That's what we're going to use on all of our lasers, actually. And so Lightburn is basically the tool that's going to give us the ability to, if you see new version, just know it, and then send a note to the Slack channel for laser cutters. So there's a new version, and one of the champions, there's like 4 or 5 of us, will come up and we'll go do an install on a different machine. We'll test it, we'll make sure it works, then we'll update the actual production machine. So we try to, anytime you, in the whole makerspace, anytime you change anything, either should be with the champion or you should be able to return it. And that's the big thing. Like, you know, some users are more proficient than other users in this space. Some people are a little older, some people are younger, some people are more comfortable. Like we try to keep it the same way you saw it last time should be the same way you see it next time.
Right.
That's the goal, get back to the standard. So if we change anything, move it back, and if it feels like an upgrade, then go change the standard. Then just let one of us know and we'll help with that. So basically, this is Lightburn, and it's a very simple application. You can do design work in here. You can do all your tool controls, which I'll show you today, as well as operate the actual machine. So I'm going to go over some very, very basic functionality in Lightburn, but there are literally thousands of people that make Lightburn content on YouTube. And it does crazy awesome stuff. So we're like literally barely going to scratch the surface. I'm going to teach you how to cut and engrave today and not hurt yourself on the machine, right? After that, there's just so much you can do. So basically, I'm just going to give a couple of examples. So I'm going to go here and I'm going to make a box. So I want to be able to make that as that box here. And when I create that box here, it does a couple of things. First thing is it sets this green dot here. And that green dot is called origin. So that's important because it's telling us here that the origin is either current position, and a user-defined origin, or an absolute coordinates, meaning you've set it on the machine, and you can set that on the machine. And so this is, if you've ever done like a CNC, this is going to be very much like a CNC work where you're actually saying this is 0, this is 0, 0, and this is home, right? So what I like to do is I like to personally use user origin, which puts your green dot on your first cut of your object. You with me on that? So it doesn't matter where it's at on the bed of the machine. It's respective of the objects that you're cutting. Okay. So like as an example, and today we're gonna do this little sample. Like somebody had made Christmas ornaments. And so as the offall of this Christmas ornaments, they had this really nice sticky backing, and they have a lot of material left over. So I thought, oh, it'll be fun. We'll cut through some of that, and then we'll test the sticky stuff. But if I want to make sure that I'm cutting that piece right here, it's very easy to set that origin when you say it's the corner of your cut, as opposed to figuring out where you're going to put this on this bed. Correct. Okay, so that's how I generally do it. So I'm looking here for user origin. I'm looking for, this is very much based on the job. Top right corner, top left corner, one of the corners, or the center of your job. And you'll notice that when you do that, it changes your origin icon, the green dot there. So we now have an object. This is a vector. So like you're cutting on your CNC machine, you got to make sure that it's a vector, which means it has a continuous line. It's not a broken line, and a vector, it has to be homogeneous. It has to have no broken parts. There's always a beginning, there's always an end. So if it's a line, a true line, it's really right back on itself. But there is all opening and a closure. This is not a vector. This is a vector. However you want to shape that vector, but can't be any opening. So this is important to remember when you start to do some different art that you might bring in. So I'm just going to take in this one, and I'm going to grab in a circle here. I'm going to say that I'd like to make a piece of toast. Let's try it that way. So I'm going to take that. I'm going to take that. So now I have two vectors. So I want to take all of this, and one of the things that you can do, just to kind of give you an idea of design here, you can actually go in here and say a Boolean resistant, and you can say I want to take those two shapes and I want to do something with them. So a union, an AB union of those two shapes, which gives us that piece of toast shape. Make sense? Yeah. And so it's going to cut that path. So I'm going to go ahead and take that. I'm going to say okay. So now I have one piece, one object, one vector. And you'll also notice that it's in the color black, and you could change it. Now it's in the color of red, etc. What's important about each of these colors is each color will do the same properties of a cut. So you're setting the cut on the color. So I'm going to go in here and I'm going to say, as an example for this one, I actually want it to cut out my toast. So I'm going to say for this one, I want the speed to be like 10 milliseconds. Let's make it a little less. That's some pretty thin material. I'm going to go 15 milliseconds. And I'm going to say at 80% power. And I'll talk about how to think about power and speed here in a minute. So that's what's going to happen here. And then before that, though, let's say I want to do an engrave. So I'm just going to do a character here, and my toast. So I'm going to take that, I'm going to bring that up here, put that in there first, and it's going to do the same thing. So that's actually, as I have it set, it's going to cut out this, and it's going to cut these letters out, right? But actually, let's say I want to engrave them. So I'm going to choose the letters, and I'm going to change its color. And here, instead of first off, instead of saying it's a line, I'm going to say I want to fill it.
Okay.
And the fill is
cut the whole thing.
Fill is going to right, and I don't want to blow through it, and so I'm going to make it kind of fast. I'm going to make that 325 by like 15% speed or 15% power. Low power, real fast, right? So, so I'm going to pause there. So now I'm going to have, this is going to say toast. It's going to cut the piece of toast. It's going to do it in this order. My recommendation is that you always do all your engraving,
First.
then do your cutting. Because whenever it cuts, it'll like fall or tweak or something. So to just get all your engraves in while it's nice and smooth, and then get your cuts in. So let's go over to the whiteboard for just a minute. And I'd love to be able to talk about how we should think about sort of this triangle that you think about: focus, power, and speed. And what's important about this is if you go, the faster you go and the lower power that you have, you're obviously going to get less power on your overall material, right? If you slow down your speed and you speed up your power, so you raise your power and you slow it down, then you're going to have more. It's going to bear down, like if you're welding.
Burning.
Right? You get a slow burn, real hot power, or same power, real fast, you're going to get a lighter cut. Does that make sense?
Mm-hmm.
But the interesting thing is I put this focus on here because what really happens is you have this laser tube, it hits mirror 1, hits mirror 2, hits the head, comes down. What's really happening is in here, it's crossing through a lens. That lens is focusing that light. So this power here, well, I don't think you want to get your hand in there. That's not where the true power is. It's not until it's focused light where you have something, right? So it's sending that laser through. So just like any, back to your science, you end up with this sort of focal point. And that focal point, if you have your material up here, you're going to have less power, because it's going to get, and your cut's going to be blown out. So if you're looking at what you're cutting and you're like, what is happening here? It's such a wide cut. Like when I was learning this, it looked like it was this little fine cut. You're out of focus for sure. That's what's happening. That's what's happening there. But depending on what you're doing, you might want that. Like it's part of using the art of the machine, right? You just know what it's doing, because you might say, I like the speed, I like the power, but I wish it wasn't so crisp. Draw it up, give it a whirl, draw it down, give it a whirl, and see how it blows out. You can actually get some pretty cool effects from that change.
Mm-hmm.
So, everybody good on how that's all working?
Yeah.
Questions on any of that?
I do have a question. As far as I know the CNC pretty well. I like to do 3-dimensional carves. I've always fantasized about like carving out a tiger head, shallow relief, and then using a laser to like burn in like the stripes. Is that possible?
Oh, yeah, for sure.
That's possible. Okay, I was curious because I never see it.
Yeah, you definitely. It's a hassle, right?
Yeah.
It's multimedia. You got to line it up.
Yeah.
Once you spent 6 or 10 hours letting that carve
Yeah.
run, you want to throw it in the laser for maybe like. right? That's the question.
Yeah. Okay. Cool.
So, you know, it's art, right? People are going to spend time and give it a whirl. But yeah, I mean, we see people do all kinds of stuff here. I mean, you'd be blown away. I personally love to do a lot of metal media and on the fiber laser, but I also love to do acrylics. You can do some really crazy stuff with acrylics. But yeah, you do it. People like.
Because I was always concerned about like if like the
Focal length here, you get, I don't know, a couple millimeters of play, maybe even 3 or 4 millimeters of play, truthfully, where it's still an effective laser. Whereas when you're on little bumblebee, that lens is finite, and you'll see this is actually from the bottom of the cone, so that where the cone is to the top of your material is 18 millimeters.
18.
That's the focal length. So you figure, you know, plus or minus, I think it's 16 or 20%, something like that. You get a little play there, right?
Yeah.
But so let's just use this as an example. This is 18 millimeters, this height.
Oh.
Right? That's your focal length. But on this lens, this is your focal length.
Oh, yeah, that's totally different.
So you get 20% of play on that, right? Or whatever the number is. And so it's just not the same score, right? So, okay, just making sure that we're good on all that. So that's that. So we have something we want to cut. We have a design. Now we have to dress the machine. And so, so basically the machine's pretty straightforward. What you're doing here is, this is the vent system. And so in this vent system, this always stays open. So red is always in good shape. You're not gonna have to worry about that. Don't close it. It's the machine, the fans draw enough that this needs to always be open. Otherwise you'll have other problems. So, but when you're using one of the other machines, Bumblebee here, you have to turn on that draw so that it starts drawing off. Okay. And then when you learn the fiber machine, it's on here. But just make sure that these are right. If you're not using one of these other ones, they're not being used while you're here and you notice them open, close them. Leave this one open all the time. So pretty much the switches are numbered. First thing I like to do is turn on the air compressor. There's a little red pole over here.
Oh, gotcha.
Get the compressor going. And then switch 1 is the top blower. Switch 2 is the bottom blower. Now we're starting to draw air. Switch 3 turns on the machine and cooling. So this guy here, this is cooling. So it's a chiller. So what's happening in real life now is, when we come back into here, water's being drawn through this chiller, comes up through the filter, comes in, and then it runs through these coils and keeps this thing cool, comes back out here. So what you're looking for is there any bubbles in there? If there's ever any bubbles in here that you can see bubbles, then you want to not use it. We can get on the Slack and get one of us up. It's rare, but it does occur. Either because it got really, really, really hot, or because the chiller evaporated water or something. A number of things. But,
does the chiller have like an automatic shut off like the CNC cooler does?
No, well, it turns off with the machine. But it'll start whistling like that if there's a problem.
Oh, okay, gotcha.
It won't shut the machine, but it'll start, you'll know. And you basically don't want to see that over 29 centigrade. If it is, you should either back off the power or wait a hot minute and let it cool off. That's good?
Sounds good.
Okay. So that's switch 1, switch 2, switch 3. I always look the thing up and look at the tube, make sure there's no bubbles in there. And now we're back to the actual machine itself. So 1, 2, 3. Make sure this is not moved. And there's a see how that line is lined up there? That's all you're looking for. Sometimes somebody will bump it and it'll move. You want it just to be all the way on. Also, sometimes people will bump the stop rather. So just turn it to unlock it. Switch 4 and switch 5 give you the light and turn the actual machine on. to activate the laser, you're going to turn the laser switch on, but just wait until you should only have that on when you're cutting. So you want the light, you want the thing, you want to be able to see what's happening. It's fine. You have the whole machine on. Just keep the laser off. When the laser switch is off, you know your hands are clear. Okay, cool. So what it did when we turned it on is it just homed, right? So you guys all know the CNC, home back, checked it, come back. It's now returned to the last time somebody told it that that was the origin. So people often say, how do I know where it was origin last time? That's what the last time. Where we turned it back on, we return to the last origin, every time. So because of that, we're saying, hey, it's okay to set a new origin. We're going to set one for every time we do a check. So that's usually the first thing I do. So this is such thin material. I think we're going to blow through the back of it. That's okay. Let's see what we do. I also just arbitrarily made this thing in size, right? So that's going to be, it's going to be way too big. We know this already. But I just kind of show you that and how I would change it and some of the approach here. So, buttons wise, here's what you got. Reset resets the controller. Escape, no matter what, if you're in a place you don't understand, just escape it, hit escape a couple times, it'll take you back to the start. Okay? Origin says, based on where I am right now, that's the new origin, that's setting origin. So when I said user-defined origin, that's what you're setting right now. We're going to go ahead and bring this over here. I'm going to say that's origin for now. So now if I were to turn the machine off and rerun it, it would come back to here. That's now the new origin. So we have that. You don't have to mess with any of these other buttons. You might want to pulse at times, which basically will fire the laser for you as long as you're holding it down. Sometimes people like to do a quick pulse to like make sure they're aligned when they think everything's perfect. It's fine. They don't, but some people do. The arrows are about moving the gantry. So left, right, back, forward. And then you see this is a Z and U. That's going to be triggering you in and out of the Z axis. So if you click Z and then up, you'll see that it changed the screen to something on it. So I'm going to actually bring this straight up. And remember that I said that your focal length is 18 millimeters. So we're going to go here. So we're pretty far from that. You don't want to just leave it in here. It'll crush between the bed and the thing, and it'll push up on the gantry. So this material is curvy, not good. So I'm going to, they have these things. They're like little clips. Yeah. They're okay. They work pretty well. So basically what I do is I'm just going to pin this down. On that side. And then I'm going to use one of these little guys on that side. And this is just tall enough that it'll clear it. Okay. So I'm gonna, I don't want to do Z anymore. I want to escape out of that. So go back into Z, up. Okay. So I'm gonna just reorigin, escape. I'm gonna reorigin that right now. So that should be origined. Should be good. If we were to fire that laser, laser on and just give it a pulse. Just see that laser hit. So we're cool. That's good. So that's where it's going to fire. So now what we do is we can go in here and we can tell it I want to frame. We use the square frame. And remember my object's way too big. But so when we click frame, if that's what it thinks it's cutting.
That's handy.
Yeah, right?
Yeah.
So that's wrong. So I'm going to go in here and I'm going to say I actually want that to be much smaller. In fact, once you have it all set, you can go up here and see I actually want that to be 1.2 by, let's say 1.2. And that way you just type it in. Now we'll go reframe that. Cool.
Mm-hmm.
So we're gonna go ahead and close this. Laser on, everything's set. I'm gonna go ahead and click start. It just is doing my toast first. And now it's going ahead with your cut action. Cool.
Pretty sweet.
All right.
Fast.
Yeah, fast. So first thing I want to do, I'm just going to kill the laser, so I'm good to safe, everything's cool. So what I do, generally speaking, is I come in and I make sure that it's free. When I'm doing a cut, the last thing you want to do is move it if you're not sure. Because if you're not sure and you don't move it, you can click start again. But if you move it, you're out. You know? So I actually think that's pretty good.
Not bad at all.
Did we melt the thing